Hey guys, let's look at some problems in the trees, permutations, and combinations section of your homework, specifically factorials, permutations, and combinations. There are 7 wires which need to be attached to a circuit board. A robotic device will attach the wires. The wires can be attached in any order, and the production manager wishes to determine which order would be fastest for the robot to use. Use the multiplication rule of counting to determine the number of possible sequences of assembly that must be tested. Okay, so basically what we're going to do is we're going to come in here. At first you have 7 choices for the first wire. Then for the second wire there's only 6 left to choose. And basically you progress your way down. There's only 5 wires, 4, and so on, until you get down to the last wire where there's only 1 choice left. Descending consecutive integers, just like this one, all the way down from 7 to 1, this is equivalent to what's called 7 factorial. An exclamation point is used to denote this type of multiplication. There will be a separate video where I show you how to do factorials, permutations, and combinations on the TI-84, and that way you don't always have to do really long multiplications like this. So let's look at how many different ways 7 wires can be attached at a time. Alright, so what I'm going to do is compute 7 factorial. If you multiply this all the way out, there's like 5,040 possible sequences. There are 3 nursing positions to be filled at Lilly Hospital. Position 1 is the day nursing supervisor, position 2 is the night nursing supervisor, and position 3 is the nursing coordinator position. There are 11 candidates qualified for all 3 of the positions. Determine the number of different ways the positions can be filled by these applicants. Now, since an applicant can't fill more than 1 position at a time, these are going to need to be taken into account the order of occurrence. So we have a day position, a night position, and then the third is the nursing coordinator. Okay. So for this first one, we have 11 candidates. Once the daytime supervisor position is filled, then there are only 10 candidates left for the night. And once that one's filled, then there are only 9 candidates left for the daytime coordinator, the nursing coordinator position. Now, if we multiply these, that's, let's see, 11 times 10, that's 110, times 9. Okay, so that gives us 990 different ways. There's also a permutations formula, 11 permute 3. Now I'm going to use permutations because the order of occurrence is important in this problem. You can also see this written as 11 factorial. In fact, this is the expanded way to do it, over the difference. Now, without using your graphing calculator, like if you're just going to use a small calculator, that first way we did it, 11 times 10 times 9, that's the quickest way to do it. But I will show you how to do these in another video specifically on the TI-84s. All right, let me get, make some room here. Okay, 11 factorial, that's multiplication with consecutive integers all the way down from 11 in this case, all the way down to 1. Our denominator is 8 factorial, so that is consecutive multiplication from 8 all the way down to 1. Now, from 8 to 1, those will have the same value. What three numbers have not canceled? Absolutely, it's the same ones from where we had our list earlier, which is still going to be 990 ways. Number 3, there are 14 qualified applicants for 4 trainee positions in a fast food management program. How many different groups of trainees can be selected? Now for this one, the order is not important. We're just grabbing a group of 4 out of 14, and we're looking for how many different ways we can do that. Now if order doesn't matter, then you have combinations. 14 choosing 4 at a time. Now with the combinations, we have 14 factorial. If you have a permutation, the difference between 14 and 4 is your denominator, but with combinations, the formula is a little bit different. You actually put the group size that you're going to choose and the difference between the overall group and how many you're choosing, just like that. There's this extra little piece to it. Okay, 14 factorial, that's consecutive integers multiplied from 14 down all the way to 1 over 4 factorial times 10 factorial, and that's from the difference between 14 and 4, okay. I'm going to go ahead and, just to illustrate, in this numerator, from 10 all the way down to 1 will cancel with this group. Four times 3 will cancel that 12, and 2 times 1 will at least reduce that to a 7, leaving us 7 times 13 times 11. Everything in the denominator got canceled. Okay, so we have 7 times 3, times 13 times 11. I get 1,001. So there are 1,001 different groups of 4 out of 14 applicants.